you need to know the rules of surds. First of all, to simplify surds, you may get something like the square root of 54. Always look for square numbers. So something that goes into 54 that's a square number is 9. So you're always looking for square numbers. So 54 is 9 times 6. So I can square root 9. So the square root of 9 is 3. The 6 I can't square root, so that stays under the bracket, under the square root sign. Watch out for adding, because if I have something like the square root of 3 plus the square root of 6, that cannot be tidied up. However, if I've got the square root of 3 multiplied by the square root of 6, I can tidy that to give me the square root of 3 times 6 is 18. That will simplify. Again, I'm looking for a square number. 9 goes into 18, so that simplifies to 3 root 2. So where you're adding surds, you can't simplify it, you can't change it, that stays like that. But if you're multiplying surds, you can bring both the things you're multiplying inside the square root. If you've got something like this, 2 root 3 plus 5 root 3, this is a bit like collecting like terms in algebra. I've got 2 lots of root 3 and I've got 5 lots of root 3, so altogether I've got 7 lots of root 3. Watch out for the difference between that and 2 root 3 multiplied by 5 root 3. The easiest way to do that is to do it's 2 times 5 times root 3 times root 3, because it doesn't matter what order I multiply in. So 2 times 5 first, and then multiply by that root 3, multiply that by that root 3. And that way you'll remember that it's 2 times 5, so it's 10. Root 3 times root 3 is just 3, so 10 times 3, that gives me 30. So when you're adding, 2 root 3 plus 5 root 3 gives me 7 lots of root 3. When you're multiplying, you need to remember that you multiply the whole thing. Cancelling surds can often give problems, and this comes up particularly when you're solving quadratic equations. So the sort of thing you might get is the bit of the quadratic formula, you might end up with something that looks like this. Minus 4 plus or minus the square root of 72 over 2. So the important thing is that you don't divide too soon. So I've got a minus 4 over 2 plus or minus the square root of 72 over 2. Minus 4 over 2 is fine, that's just minus 2. But I can't cancel this unless I've simplified the surd. So again, I'm looking for square numbers. So a square number that goes into 72 is 36. So 72 is 2 lots of 36. I bring the square of 36 is 6. So I bring 6 outside. I've still got root 2 in the bracket, and it's over 2. Now the bit that I can cancel is the 6 and the 2. I can't cancel the square root, but I can cancel the 6 and the 2 to give me minus 2 plus or minus 3 times the square root of 2. So that's cancelling surds, particularly useful when you're using the quadratic formula. You will also have or see the phrase rationalise or rationalising the denominator. Rationalising the denominator, there's 2 different types. There's one where you've got something like this, 3 over the square root of 2. To rationalise that denominator, I need to get rid of the square root of 2. So what I do is I multiply by the same thing, top and bottom. Root 2 times root 2 will give me, root 2 times root 2 will give me 2. And then on the top line, I've got 3 times root 2. So the numerator is just 3 root 2 over 2. And remember, I can't cancel these 2's because this is inside a square root and this isn't. So I can't cancel the 2's. The other sort of rationalising the denominator you get, and you need to just learn this one. Something like 5 plus root 3 over 2 plus root 3. You need to learn the method for this. You look at the denominator first, and to rationalise this denominator, I've got 2 plus root 3. I need to multiply by 2 minus root 3. So I have a change of sign. I've got to keep the fraction the same, so if I'm multiplying by 2 minus root 3 on the denominator, I also need to multiply the numerator by 2 minus root 3. Do your multiplications. So I've got 2 times 2 is 4. A plus 2 root 3 and a minus 2 root 3, those two will cancel out. And that's the whole point of this method. And then at the end I've got a plus root 3 times minus root 3. So plus times a minus is a minus. Root 3 times root 3 just gives me root 3. The numerator, I'll have all 4 terms. So I've got 5 times 2 is 10. 2 times root 3. I've got 5 times minus root 3. So that's minus 5 root 3. And finally plus root 3 times minus root 3, which gives me minus 3. So you should get 2 normal numbers and 2 square roots. I then need to tidy it up, so I've got a 10 minus 3, which is 7. 2 root 3 minus 5 root 3 is a minus 3 root 3, and that's over 4 minus 3, which is 1. So the answer is 7 minus 3 root 3. That's a very standard method.